Hello student, myself Dr. Swati Talele working in Sandeep Institute of Pharmaceutical Sciences will start the course Pharmaceutical Engineering, Unit Flow of Fluid. Second lecture, so we'll discuss the energy losses, detailed discussion on types of energy losses, measurement of rate of fluid flow, detailed discussion on hydrodynamic method, and lastly the discussion on the direct weighing and displacement method. So before starting energy losses, in last lecture we had already discussed about the flow of fluid including fluid statics, fluid dynamics, then Reynolds number, then Reynolds experiment, manometer and its type, then Bernoulli's theorem. So in today's talk I will discuss about the energy losses. So what do you mean by energy losses? Now, before discussing this energy losses, just remind in Bernoulli's theorem, we had discussed about the total energy per unit mass consists of the pressure energy, potential energy and kinetic energy at the point of any fluid is constant and energy added by the pump is W, whereas the loss of energy due to the friction is F. And according to the law of conservation of energy, the energy balance has to be properly calculated. So fluid experiences the energy losses in the several ways while flowing through pipe, and these are very first one, frictional losses, then losses in the fitting, enlargement losses, and last contraction losses. So let's discuss about the frictional losses. Now frictional losses, these are occurred whenever the flow of fluid causes the loss in pressure. So type of fluid flow including turbulent as well as the viscous flow influences the losses. Now what do you mean by turbulent flow and viscous flow? This we already discussed in very first lecture, that is in Reynolds experiment. Now this general, that is pressure drop, this has to be occurred due to the friction in liquid. So pressure drop, it is related, or rather we can say the pressure drop directly proportional to the velocity, then density of the fluid, length of the pipe as well as 1 upon diameter of the pipe, and all these parameters it utilized in fanning equation. So why the fanning equation is utilized? So this is utilized for calculating the frictional losses, and whenever the fluid flowing through the straight pipe, this equation has most probably get utilized. So how this fanning equation you can write? So this fanning equation as given, delta P is equal to 2F U square L into rho divided by D. So F is the friction factor, D is the diameter of pipe, delta P is pressure drop, and L is the length of pipe. So fanning equation as shown in this, that is pressure drop directly proportional to this, all these factors it included in this fanning equation. Now next one, what do you mean by this friction factor? Okay, so this friction factor, this is totally depends upon the various following factor. This included the nature of flow. So nature of flow we had discussed about that is viscous as well as the turbulent flow. So whether the flow is viscous or the turbulent flow. Then second one is the roughness of inner surface of the pipe, and here this table it indicates what, that is condition of pipe and the roughness factor. If you observe this table, it indicates what, that is the badly rusted iron pipe have the higher roughness factor, whereas the smooth brass, copper as well as the lead pipe has the less roughness factor. New steel or the cast iron pipe has 1 as a roughness factor, old steel pipe has 1.6 as a roughness factor, whereas the badly rusted cast iron pipe has the highest roughness factor. Now, this Hagen-Poiseuille equation, it has utilized for the viscous flow pressure drop, and it has given with the equation 32 L into U into N divided by D square. So frictional losses, these are not a temporary, these are permanent. So why the friction losses are permanent? This is just because of potential energy and the kinetic energy converted into the heat. So this is all about what? The frictional losses. Now next we will see the losses in fitting. Now we already discussed the fanning equation. It is applicable for the losses in the straight pipe, and whenever the fittings are introduced into the straight pipe, so this fittings, it will causes some sort of disturbances for the flow of fluid, and which results in what? The additional losses of energy. So loss in fitting, this is occur. Why it is occur? This is just because of change in direction or change in the type of fitting. Change in direction, it is related to example, that is nothing but the elbow fitting. Then change in the type of fitting, this is related to what here? Coupling. Then the wall meter. Okay, so these are the two examples of change in direction and change in type of fitting. Now as shown in this diagram, some equivalent length has mentioned for this elbow fitting, then T fitting, then coupling fitting, as well as the globe wall coupling. Now equivalent length of fitting, it has calculated with the help of the equation equivalent length into the internal diameter. Now we'll take one example. This globe wall, it has the length, equivalent length 300 and internal diameter as a 15. So after calculation, you will get the value as a 15 meter. So what this 15 meter it indicates? This indicates what? That is globe wall is equal to the 15 meter straight line. So this length, it is substituted in fanning equation to obtain the energy loss due to the fitting. So the fanning equation, again, it is applicable for the losses in fitting. Now in this we will discuss, that is gradual contraction as well as a sudden contraction. Okay, now if the cross section of the pipe, it enlarges suddenly, or it is the that is sudden as well as the gradual one. First we will see here the gradual cross section of the pipe enlarges. So fluid adapt itself to the change section without any disturbances. So it will causes what? No loss of energy. But if here the cross section of the pipe changes suddenly, then the losses in the energy, it is observed due to the eddies, and these are the greater at this point than the straight line pipe. So from this one we can say that here U2 is less than the U1. So U1 is greater than U2. Okay. So for sudden enlargement, we can write the equation delta H. That delta H, it is nothing but the loss of head due to the sudden enlargement is equal to U1 minus U2 divided by into 2 divided by 2g. G is the acceleration due to the gravity. Okay. So here we can observe as the vena contracta. So vena contracta, this is nothing but here the point of, see here, the point of minimum cross section, it is called as what? Vena contracta. So student, just keep it in mind, the gradual contraction, it leads to no loss of energy, whereas the sudden contraction, it leads to the loss of energy. Now this we will again explain with the help of taking the very routine example, that is the tomato sauce bottle, which is filled with the sauce, and when we try to invert it, the velocity of the tomato sauce is minimum. Okay, at the middle portion. but when it approaches near the neck portion, okay, it will causes what here, the suddenly it will be come as a sauce, that is the suddenly velocity of that sauce, it will be get increases. So with that example we can say that here gradual contraction and the sudden contraction. So this is all about what here, the losses in fitting. Than the contraction losses. Now contraction losses, again in this diagram we'll see the gradual contraction and the sudden contraction. So if the cross section of the pipe is reduced suddenly, the fluid flow is get disturbed and the diameter of the fluid stream is less than the initial value, and this is nothing but here the vena contracta. So we already discussed the point of minimum cross section is known as the vena contracta, and the velocity of fluid at the smaller cross section will be greater than at the larger cross section. So U2 is greater than U1. So that is all about what, the contraction losses. Now sudden contraction losses as given by the equation delta HC is equal to K into U square divided by 2G. So delta HC is nothing but loss in head due to sudden contraction. K is constant, U square is the velocity. Now, next part, measurement of rate of flow of fluid. Now, in this measurement of the rate of flow of fluid, the first method, hydrodynamic method, which is classified into the orifice meter, then Venturimeter, Pitot tube, then next type, that is the rotometer, then next direct weighing or the measuring, then the direct displacement meter. Now, let us see about the orifice meter. The orifice meter, it is also called as what? The variable head meter. Now, this variable head meter, it based upon principle. This orifice meter is the thin plate containing a narrow as well as a sharp aperture. So when the fluid stream is allowed to pass through the narrow constriction, the velocity of fluid is increases compared to that of the upstream. And this causes what here? The decrease in pressure head, and the difference in pressure may be read from a manometer which is attached from point A as well as the B, and this is indicated with the help of equation U square is equal to C0 under root of 2G into delta H. So C0, it is the constant or it is the coefficient. Now let us see here the construction of this orifice meter. So orifice meter, it is considered as the thin plate containing a sharp aperture through which the fluid is flowing. So normally here it is to be placed in between the long straight pipe, so that here other fittings it will not alter and the flow rate that is being measured. So it is possible to place the orifice meter in the side or at the bottom, but for the present discussion, this plate, it is to be placed in to the pipe, and the manometer, it has to be connected in between the point A as well as the B. Now let us see the working. Now we already discussed, it is referred as the variable head meter. It measures the variations in the pressure across the fixed constriction, place in the path of flow consisting of the constant area. So when the fluid stream is allowed to pass through the cross section of the orifice, the velocity of fluid at point B increases with decrease in the pressure head. So as a result, the pressure at the point A is greater than that of at the B. So this difference in the pressure head, it can be calculated with the help of what? Manometer, which is attached in between the point A as well as the B. So this is all about what? The orifice meter, which is nothing but variable head meter. Then let us discuss about the Venturimeter. Now this Venturimeter, it is the base upon the principle when the fluid is allowed to pass through the narrow venturi throat, then the velocity of fluid is increases and the pressure decreases, and the difference in the upstream and the downstream head can be measured with the help of the manometer. So again at point A and B, this manometer has attached, and the equation which has to get utilized for the determination, that is UV is equal to CV under root of 2G into delta H. So let us see here the construction. So the Venturimeter, it consists of two tapered section as shown in the diagram, which is inserted in a pipeline. So normally Venturimeter is placed in between the long straight pipe. Again you have to just keep it in mind here. This Venturimeter, it has to be placed in between the long straight pipe, so that here the other fittings will not alter the flow rate that is being measured. So upstream cone is normally shorter than that of the downstream. Okay. So here the tappers, these are to be smooth as well as the gradual one. Now in addition, the cross section of the high velocity part of the stream is well defined, and the manometer, it has to be attached in between the A as well as the B. So in short, you have to just keep it in mind, the inlet section, then outlet section, then tapered ends are there, then this is the throat of venturi. So long tapered section, short tapered section, then the velocity head, it will increases at this throat of venturi, whereas the pressure head, it will be get decreases. Okay. Now let us see about the working. So Venturimeter, it is referred as the variable head meter. That means it measures the variable differential pressure across the fixed constriction which is placed in the path of flow, which consists of the constant area. As we already seen in the orifice meter, the constant area has noted. Then in Venturimeter, the velocity of fluid is increased at the throat due to the constriction, and this results in what? The decrease in the pressure head. So pressure drop in the upstream cone is utilized to measure the rate of flow using this manometer, which has attached in between A and B. So thus Venturimeter, it's nearly confirm the theoretical equation which is obtained for the orifice meter. Okay. So the equation which has utilized for this Venturimeter, it has already noted. So this is all about the Venturimeter. Now next we'll see about what is difference between the orifice meter and Venturimeter. So if you see the difference, orifice meter is near about cheap, whereas the Venturimeter, it is expensive. So why here this difference? Because orifice meter, it is the homemade construction. It is easy to install. Whereas the Venturimeter, it should be purchased from the instrument dealer. Then fabrication is highly technical. Whereas the next difference, head losses are more. Whereas in this case, head losses are insignificant. Then power losses are again more. Whereas in Venturimeter, power losses are less. Then orifice meter, it is used for the testing purposes, then it is used for in online installation. And last one, orifice meter has a greater flexibility, but Venturimeter lacks this flexibility. It is the permanent one. So this is the difference in between the orifice meter and the Venturimeter. Now let us discuss the next, that is the Pitot tube. So Pitot tube, it is called as the insertion meter. Okay, so let us see here initially the principle. So Pitot tube, it consists of the sensing element with the small constriction compared to the size of flow of channel. So when the sensing element it is to be inserted at the center of stream, it will leads to what? Increase in velocity, and it will causes the decrease in pressure head. So tube at right angles to the flow, it measure the pressure head as shown in this diagram. Whereas here this tube which is near about the parallel, it will be measured parallel to that of the flow of fluid, measures the pressure as well as the velocity head. So here it is again mentioned the principle. The tube at right angles to the flow measure the pressure head, and tube pointed upstream measure the pressure head as well as the velocity head. And then difference in between these two, it indicates the velocity head, which is given by this R. So according to the Bernoulli's theorem here, this we already discussed, the total energy at any point, it has given by the equation potential energy plus the pressure energy plus kinetic energy. And we had discussed already this equation, U0 is equal to C0 under root of TG 2G into delta H. So delta H again we had discussed difference in the pressure here. So this equation it has written, that is delta H is equal to U square divided by 2G, which indicates what? The velocity. U indicates as what? The velocity at the point of insertion. So let us discuss in short the construction of this Pitot tube. So construction of Pitot tube as shown in this diagram. As we already seen, Pitot tube, it is called as the insertion meter. Now the size of the sensing element is small compared to that of the size of flow of channel. This is again necessary during the construction. The next thing is what here? The point of measurement may be at the center of the channel, and one tube it is to be perpendicular to the flow of direction, and the second tube it should be connected parallel to the direction of flow, as we already discussed in a principle. So two tubes, these are to be connected to the manometer, and here the R has to be measured. Then next we'll see about the working. Now in working, these two tubes are inserted into the pipe in a manner as shown in this diagram. Then this Pitot tube is used to measure the velocity head of the flow. Then in this tube, the velocity of fluid is increased at the narrow constriction, and this result in the decreased pressure. Whereas the tube at the right angles to the flow, it measures the pressure head only, and tubes that points upstream measures the pressure head as well as the velocity head, and the difference in the above reading, it indicates the velocity head. So therefore the reading R of the manometer, it measures the velocity head. So this Pitot tube, it is mostly measure the velocity at the point only. So this is all about the Pitot tube. Then we'll discuss about the next, that is rotometer. Now rotometer, it has based on principle, that is in this device a stream of water it will enters the transparent tapered tube, and it strikes the moving plummet. So during the fluid flow, this plummet rise or the fall. So as the plummet rise and fall, this results the annular space or the area in between plummet as well as the tapered tube may increase or the decreases depending on the variation of flow rate, and the head loss across the annulus is equal to the weight of plummet. So let us see here in short the construction. So this rotometer, it consists of vertical tapered tube, which is mounted with the narrow end rods. Okay, that is end down, it will be given narrow end down. Then tube is usually made up of glass on which the linear scale is inserted as shown in this diagram. Then a solid plummet is placed in this tube, so which is shown by the in this diagram, float or the plummet. Then the diameter of the plummet is smaller than the narrowest part of the tube. And rotameters, it is available, this rotameter, it is available with electric and electronic transmitter for the recording. So floats of the different densities are available, so that 200-fold range of flow can be measured accurately. And what is that is the float, how actually it made up of? It made up of either lead, aluminum, glass, as well as the plastic. Now let us see here the working of this rotameter. So as the flow is upward through the taper tube, the flow of fluid, it will be varies. So plummet, which is surrounded as shown in this diagram, the plummet which is surrounded by the fluid, it will be rises and falls depending on the rate of flow. So the greater the flow rate, the higher the plummet, it will be get rise in the tube. So in rotameter, the pressure drop is constant or nearly constant. So during the fluid flow, the area of the annular space between the plummet and the tube, it will be get varies. Therefore, the head loss across the annulus is equal to the weight of plummet. And we have seen in this principle, that is head loss across the annulus is equal to the weight of plummet. And the flow may be read using the upper edge of the plummet as an indices. So area is the properly calibrated to the flow rate, and the readings, it may be transmitted for the recording, then for integrating, and then for controlling. So this is all about the rotameter. Then next one, the direct displacement meter. So direct displacement meter, it has based on principle. This is used for the measurement of flow of fluid in small lines. And whenever the stream of water enters the meter and it strikes the moving part, so rate of rotation of moving part is directly proportional to the velocity of water passing through meter. And the displacement of moving part transmitted through the train of gears to the counting dial, which is located at the top of moving part. So this is all about what? The direct displacement meter. Then next type, direct weighing or measuring. So direct weighing and measuring, this is related to what? Whenever the any type of fluid, it will be flowing through the pipe, it is collected for the specific period at any point, and then it is weighed and then measured, and the rate of flow, it can be get determined. Now gases, it cannot be determined with the help of this direct weighing or the measuring method. So this method generally considered as impractical. So on commercial basis, this is not convenient to weigh the liquid. Now this is student all about the measurement of rate of flow of fluid as well as the energy losses. So we have completed about here, that is the first lecture included, we already discussed, that is the flow of fluid, fluid statics, then fluid dynamics, then Reynolds number, Reynolds experiment, then we have seen manometer, types of manometer, then Bernoulli's theorem. So these are some of probable question which is asked generally for the 2 marks. Then again for the 5 marks, these are some probable questions. Then long question for the 10 marks. So these included some of the questions. So student, in this lesson, what we have learned. So we have learned about that is energy losses. What are the various types of energy losses? Then we have discussed about the measurement of rate of flow of fluid. What are various types? That is including hydrodynamic method, direct weighing as well as the displacement method. Then we have discussed about orifice meter, venturimeter. What is the difference in between orifice meter and the venturimeter? So these are all about the energy losses and the measurement of rate of flow of fluid. So thank you student. Hope you understand about the very first unit flow of fluid. So thank you.